Hello everyone. In this video, I am going to discuss the remaining solution of the data science assignment. I'd already discussed the 5 beginning questions of this assignment, and in this video, I am going to discuss the remaining 5 questions, starting with the question number 6 of this assignment that asks for define overfitting and underfitting in the context of machine learning models and describe how these issues can be identified and list strategies to prevent or mitigate them. So overfitting occurs when a model memorizes noise. That is, it performs better on the test data, but it does not perform well on the new data. It giving very low training or error, but high validation or test error. Underfitting arises when a model is too simple, performing poorly on both training and test data. How we can describe how these issues can be identified? These issues can be identified by comparing the learning curves of the training versus validation, loss, or accuracy. And we can perform mitigation for overfitting. We can use regularization, dropout, pruning, data augmentation, and early stopping. Whereas for underfitting, we can increase the model capacity, features, or training time to get better results. Next, question number 7 asks for differentiate logistic regression and linear regression on the basis of hypothesis parameters and the cost function. How gradient descent algorithm is used to optimize the parameter. So, logistic regression predicts the probability of a binary class using the hypothesis h theta of x is equal to sigma of theta to the power theta transform of x and the logistic log loss cost. Linear regression predicts the continuous value with hypothesis h theta of x is equal to theta to the power transform of x and mean squared error cost. Here the aspect involved the linear regression outputs the continuous value, whereas logistic regression outputs a probability in the range of 0 to 1. Linear regression gives the hypothesis linear function theta of t of x to theta of t into x, whereas logistic regression gives a hypothesis in the form of sigmoid or linear term. The linear regression cost is a mean squared error or least squares, whereas logistic regression cost is a gross entropy or log loss. Now, gradient descent updates each parameter, that is theta of j is equal to theta of j minus alpha derivative of j with respect to the theta j, iteratively moving opposite the cost gradient until convergence for both models occurs. Now let's move to the question number 8. It asks to write a program in Python to implement the logistic regression and linear regression. For every method, compute and display the implemented model's evaluation measures, whichever is available, such as accuracy and other value of different valuation metrics such as confusion matrix, accuracy, precision, and recall, F1 score, specificity, and loss function, RMSE, and R2 score. So first of all, we are creating a general Python code logistic regression for logistic regression or classification. We import the numpy SNP from sklearn dot model selection. We import the train test split, and uh, from the same sklearn dot linear model, we import logistic regression, and sklearn from sklearn dot matrix we import the confusion matrix, accuracy score, precision score, recall score, F1 score, classification report. Then we define the feature matrix by x and the binary labels as y, where x train, x test, y train, y test is equal to the train test split x, y test size is taken as 0.3 and random state as 0. We will take the model log is equal to logistic regression, pass logistic regression to the model log, and then model log will be fitted with x train and y train, and y prediction will give the value of model log predict of x test. We will use the variable cm to represent confusion matrix for y test, y prediction, acc for accuracy score with y test and y prediction, prec prec for precision score for y test and y prediction, and F1 rec rec for recall score with y test and y prediction as the arguments. F1 is equal to F1 score for y test and y prediction, and we can pass the tn fp fn tp is equal to cm dot travel, and it will perform our necessary operation and give the and we can calculate the specificity as equal to Tn divided by Tn plus Fp. And finally, we can print the logistic regression with confusion matrix Cm, accuracy ACC, precision rec, recall as sensitivity rec, specificity specificity specificity, and we can print the F1 score as F1. And finally, we can print the classification report as Y test, Y prediction. Next, here is a general linear regression. We can import linear regression from sklearn.linear model. Then we can import mean squared error and R2 score from the sklearn.matrix. Then we can import square root from math, and we can XR train, XR test, and YR train, YR test is equal to train test split, and where XR comma YR and test size is equal to 0.3 and random state are passed as the argument for the train test split. Then we perform model linear regression and pass linear regression to it, and then we can fit it with XR train and YR train, and YR prediction will be calculated by model linear dot predict SR test, and mean square, where the mean square error is calculated as by taking the arguments YR test and YR prediction, and RMSE can be calculated by taking square root of MSE as an argument, and then R2 can be calculated as R2 score, where YR test and YR prediction are the arguments. And finally, we can print the linear regression, RMSE, and R2 score. Next, write one hot encoding for the given data. So, the fruits are here apple, mango, apple, oranges with the numeric values and prices. So, we can perform a general one hot encoding which creates one binary column per unique fruit, apple, mango, orange. So, resulting encoding table will give for apple the value will be 1 and price 5. Then again the value of apple will be 1, mango will be 0 and 0. So 1 0 0 will be the representation for apple. For mango it will be 0 1 0. For apple again it will give 1 0 0 representation. For orange it will give 0 0 1 representation, because here the value for apple is 1 while mango and oranges are not present, so 1 0 0. Similarly, mango is present, but orange and apple are not present. So 0 1 0 is the representation. But here again apple is present, but mango and orange is not present. So 1 0 0, and orange is present, but apple and mango is not present. So 0 0 1 representation. Let's move to the next question. This is the final question of our assignment, which asks that why k nearest neighbor is considered as lazy learning. Discuss the k nearest neighbor. Consider the following table. It consists of height, age, and weight. Target value for the 10 people. The weight value of ID11 is missing. Predict the weight of this person ID11 based on their height and age. So the KNN is called lazy because it stores training data and does not know model building. All computation or distance voting averaging happens only when a query point must be predicted. Whereas for ID11, that is here the height 5.5, and for ID111 5 point with height 5.5 and the age 38, we can compute the Euclidean distance to all the points in height or age space and choose say k is equal to 3, and we will get the nearest 3 records as ID6, that is 560 kg, and 5 72 kg, and 4 the weight 59 kg. So finally we can predict the average weight as 60 plus 72 plus 59 divided by 3 and get the 63.7 as the predicted age, which will be nearly equal to 64 kg. That will give our respective answer. Thank you very much for listening.